Welcome to Maths and Science by IITian. To this channel, and today I want to start another chapter in Maths and Science useful for JEE and Maths Olympiad. We have completed vectors. I don't say we have completed, rather we have discussed at length about the vectors and then some amount of number theory and complex analysis that is required for JEE and Maths Olympiad. Now, we will switch on to linear algebra. It is called as linear algebra, and in linear algebra, we have a syllabus of matrices and determinants and their properties, definitions, calculations, simultaneous equations. These are all dealt in the bigger picture of linear algebra. We will not be going into the vector spaces, which is the advanced course in the linear algebra. We will be constraining ourselves to matrices, determinants, its properties, and simultaneous equations, their behavior, eigenvalues, and eigenvectors. As a sample, I have taken eigenvalues as one of the topics today, so that I will just brief about the matrices, determinants, and then we will switch to eigenvalues so that you will understand and you will appreciate the uses of matrices in our day-to-day life and also in science, advanced science like quantum mechanics. Let us start the topic now. Eigenvalues. Before going into the eigenvalues, here only I will give what is the definition of matrix, but however, we will deal in detail in the following classes. Matrix is a rectangular array of arrangement of elements in it. Please try to understand the concept instead of concentrating the definitions as per book. Now, I have a matrix, I have certain things, an element A11 and an element A12, an element A13 and another element A21, A22, A23 and another element A31, A32, A33. Let us say these are all arbitrary numbers. Then this is a 3 by 3 matrix, and in this 3 by 3 matrix, what is first 3? First 3 is number of rows, row number, and second 3 is column number. For example, A11, if something starts with A1 means it is the first row, A11, A12, A13, this is first row. A21, A22, A23 is second row. A31, A32, A33, it is very important to understand this, because usually people make mistakes in this only, in understanding. This A11, 1 is at the second, that means 3 by 3 matrix, second part is, second suffix is 1 means it is first column. Here in this, suffix is 2, second suffix, hence second column. And here suffix is 3, second suffix, hence it is third column. Now, I want a number or an element which is in the second row and third column. Second row and third column means second row is 2, third column is A23. If I want A23, where it is, how to locate it? Second row. Second row is this one and second column. Where is the second row? Third column. Third column is this one and second row is this one, this is A23. That means we can identify an element in a matrix. It is a 3 by 3 matrix, okay, we are able to do it. It can be an infinite by infinite matrix also. The number of rows may go from 1 to infinite. Number of columns may be up to infinite. I may be exaggerating, but it's possible. In that case, if you want a particular element, then this representation will help us. And it is very good representation of elements in a rows and columns will be very useful for computer science studies and data analysis. I have been given a very big data of some 1000 rows and 1000 columns representing different parameters, properties. For example, first column may say gender, second column may say age group, third column may say their habit. That means how many people fall under the gender, particular gender. How many fall under the age group of so and so. How many have the habit of reading books, morning walk, like these habits, playing cricket. These habits how many people have. That is A11, A12, A13. And in rows, we can have different students like class 10th students, class 11th students, class 12th students. So that this much data of 9 numbers we have embedded in a simple matrix. And if I want class 11 students of 13 to 15 age group or 17 to 19 age group, how many people are there means with the help of this I will be able to find out A22. Like this arrangements in the matrix are made, and this is picked up in the computer science and data analysis, especially in data analysis. Now, next comes this matrix where it will be useful. One is computer science and data analysis, and second is research. Whenever some research takes place in medical sciences, that research on medical sciences, they do the research of a particular medicine effect on certain group of gender people and certain group of age group people, certain group of people who has got the disease in an advanced stage. All these also you can put in the matrix form. Medicine, engineering, computer science, data analysis, in physics, vibrations, structural analysis, a structure is there. A structure is there like this, a multi-story building in which this is the foundation, and there are many columns, many floors, like this structure is there. It is numbered. Number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like this. These are all nodes. These are all nodes where we are supposed to know the structural stability. What are the forces acting on it? What are the moments acting on it? Whether that particular strength of the material is going to take care of that particular force acting on that particular node and particular member. These are all can also be done by matrices and determinants. And in engineering, mechanical engineering, you will have a lot of structures where vibrations do take place because of machine rotation, dynamics. Those vibrational analysis can also be done by matrix. In quantum mechanics, we are not aware. Quantum mechanics mainly deals with the probability, Schrodinger equation, probability. In that, we don't know the particle where it is at that particular point of time. We want to know. We can develop a matrix, and from that data analysis, we can make out this particular probability of this particle to be in that particular position is possible with the matrix. Now, once you understood the matrix and arrangement of matrices, the types of matrix and other introduction I will be giving in the next class onwards. In this class, I want to touch only the most relevant, important concept development. Now, for example, a matrix is there like this. It is denoted by a capital letter. Matrix should be written like this in the brackets, rectangular brackets. A11, A12, A13, A21, A22. It should be a practice for you to write. Why I am writing here? Because I want you to make practice of it. So you should not interchange columns and rows. It's not good. Maintain a particular habit. And if it is of Mn shape, that is A11, A12, A13 up to A1n, and this is up to AM1, AM2, AM3 and up to AMN. In this case, it is a M by N matrix. M rows and N columns. Now, what is this particular element? Any particular element of AI. Aij means any element Aij is equal to ith row jth column element. As I told you, A23 means second row, third column. That is Aij. A general matrix can have different elements Aij and I extending from 1 to infinity, j extending from 1 to infinity. That is the matrix, simpler form of the matrix. Now, there is one property called determinant of a matrix. Why determinant is important? What is it? Let us now think about determinant. All these things I will in detail talk from the next class onwards. Here only I am giving an outlay. Determinant. For example, I have an equation, simultaneous equation, 2x plus 3y is equal to 7 and 3x minus 4y is equal to 5. I want to find out x and y. What I will do, from my mathematics I learnt till my SSC secondary school in the elementary classes, what I will do? I will write the first equation like this only, and I want to make one of the x or y component as minus so that the sum will be 0. This 3x to be equal to 2x and it should be made 0, that sum. Then I should multiply this with minus 2 by 3. Minus 2 by 3 into 3x minus 4y is equal to 5. Do you agree? In a systematic way we are solving. What happens? 2x plus 3y is equal to 7. It remains as it is. Minus 2 by 3 means minus 2 by 3 into 3 is minus 2x. Minus into minus is a plus. 2 by 3 into 4 by 4 is equal to 8 by 3. Y is equal to minus 2 by 3 into 5 is minus 10 by 3. Do you agree? Then we will add up these two. What happens? Minus 2x will go. That will be 0. 3y plus 8 by 3y will be 17 by 3y. That is equal to 7 minus 10 by 3. 7 minus 10 by 3 means 21 minus 10, 11 by 3. That implies 17 by 3y is equal to 11 by 3. That means 17y is equal to 11. That means y is equal to 11 minus 11 by 17. Do you agree with this? Please check and find out x also. X is 2x plus 3y is equal to 7. That implies 2x is equal to 7 minus 3y. That is equal to 7 minus 3 into 11 by 7. 49 minus 33 is 16 by 7. That means x is equal to 8 by 7. We could solve this equation because it is only two variables are there, two unknowns and two equations. When number of variables are there, number of variables is equal to n is equal to m, number of equations. Number of variables is equal to number of equations. Then we have a solution. And that solution can be in this way. And this will be cumbersome or little bit, what you call, we can say, heavy or tough, or it will be lengthy when number of equations and number of variables are very high. Let us say number of variables is equal to 100. Number of equations is equal to 100. Is it possible to solve it manually? No, it's not possible. We should have a method to solve it. That particular method is, there are many methods to solve for xy. One is, we can say, inverse method. By finding the inverse of the given matrix, we can find the xy values. Second, Cayley-Hamilton theorem. Cayley-Hamilton theorem, and another is Cramer's rule, that is to find the inverse. And Cayley-Hamilton theorem, it uses characteristic equation. Characteristic equation comes from determinants. That means to solve the simultaneous equation, there is not only one simple method, there are various methods, out of which characteristic equation method is the easiest. I will talk about characteristic equation now. Let us talk about determinant. In this, let us say I want to solve an equation x plus 2y is equal to 5 and 2x plus 4y is equal to 10. Can you solve this? X plus 2y is equal to 5, 2x plus 4y is equal to 10. If I multiply the first equation with 2, then I will get the second equation. We can't solve it. Then we are analyzing the simultaneous equations. These are called simultaneous equations. In such a way, whether it has infinite solutions, no solution at all, or a unique solution, because these are the possibilities. You tell me, in this equation x plus 2y is equal to 5 and 2x plus 4y is equal to 10, how many solutions are there? Because both the equations represent the same. From this, what we can say? X is equal to 5 minus 2y. If y is equal to 1, x is equal to 3. If y is equal to 1, x is equal to 3. If y is equal to 2, x is equal to 1. That means there are infinite solutions. There are many solutions for this set of equations. For this set of equations, there are infinite solutions. Now, I have got 100 by 100 matrix. I can't go on checking each and every that where is this what you call similar type of equations. In that case, what I have to do? I have to find out some way where I can find out whether particular simultaneous equation is solvable or not. If solvable, how many solutions are there, and whether there are infinite solutions. In that case, determinant comes into help. Now, we have solved one equation called 2x plus 3y is equal to 7. We will take up the same examples. One set is 2x plus 3y is equal to 7. Second set is 3x minus 4y is equal to 5. And second equation, x plus 2y is equal to 5. 2x plus 4y is equal to 10. It has first one has a unique solution, second one has infinite solutions. How to find out? There is one term called as determinant. Delta. Left hand side, in first case, left hand side can be represented as a matrix 2, 3, 3 minus 4. This is like vector. Matrix is nothing but dealing with vector. 2x plus 3y, first row is 2 and 3, components of x and y. It can be I and j and k also. 2i plus 3j plus 4k, like that. And say this is the first row. Please see, this is first row. This is second row. In the first row, 2x plus 3y, that is 2 and 3. The components only we are writing. In the second row, 3 and minus 4. This is how a matrix is written. I am not writing the extended matrix. It is a matrix of the left hand side. Representation. Now, for this matrix, let us try to find out the determinant. Determinant will be put into lines, that is like absolute value. It's a value. Determinant is a value. Matrix is a vector. For finding the determinant, what we have to do? The first row element, like cross multiplication, this should be multiplied with this, and this should be multiplied with this, and both are to be subtracted from each other. 2 into minus 4 is minus 8. Minus 3 into 3, that is equal to minus 8 minus 9, that is equal to minus 17. This is the determinant of first. Now, let us come to the second case. 1, 2, 2, 4. That is equal to, what is the determinant? 1, 2, 2, 4. 1 into 4 minus 2 into 2. That is equal to 1 into 4 minus 2 into 2. That is equal to 0. That means whenever a determinant is 0, you don't have a unique solution, and solution is defined in other way than the unique solution. When determinant is not equal to 0, that implies determinant is equal to 0. This implies determinant is not equal to 0. These are the two cases. By finding the determinant, we can say whether a particular set of simultaneous equations, they have the solution or they don't have the solution. And if they have the solution, what type of infinite solutions or finite solutions, unique solutions. This is very, very important topic. I will be taking up whenever as we proceed on to the lectures. Now, the last and most important topic that requires your attention in this is eigenvalue and or characteristic equation. Let us talk about characteristic equation first. Now, let us take the same example 2, 3, 3 minus 4. First case 2, 3, 3 minus 4 and second case 1, 2, 2, 4. These are the two matrices given to you. I am taking simple matrices 2 by 2 because I want you to make aware of the concept. Once we dwell into the details of the topic as we move on, then we will do very difficult, tough 3 by 3 matrix and we will do bigger than that very easily. I will tell one by one procedure. In this case, what is the determinant? 2, 3, 3 minus 4. Here determinant 1, 2, 2, 4. If I say there is one thing called unit matrix I, that is 1, 0, 0, 1. The first row has got only one element, that is A11, that is equal to unity. Like that each row has got only one element, that is called unity. A11, A22, A33, everything is unity. A11 is equal to A22 is equal to A33 and so on is equal to 1. That is the definition of a unit matrix. That means Aij is equal to 1 when I is equal to j. That means column and row number should be same, then the element should be equal to 1. If the element is equal to 1, then that is called as unit matrix. Now, you cannot add or subtract a number, direct number from the matrix. You have to add or subtract a matrix from a matrix. Hence, if you want to add matrix plus 3, that's not possible, but matrix plus 3i is possible. Similarly, in this case what happens? 2, 3, 3 minus 4 is a 2 by 2 matrix minus lambda into I gives what? Some lambda I am taking. 2, 3, 3 minus 4 minus lambda into 1, 0, 0, 1. That is equal to 2, 3, 3 minus 4 minus lambda 0, 0, lambda. As I explained in the vectors, matrices are also vectors. We cannot add the numbers just like that. We have to add these two numbers, add or subtract these two numbers separately. These two numbers we can add and these two numbers separately. This gives 2 minus lambda, 3 minus 0 is 3, 3 minus 0 is 3, minus 4 minus lambda. For finding the characteristic equation, A minus lambda I to be developed. Matrix A minus lambda I to be developed. Afterwards, you make determinant of A minus lambda I is equal to 0. That means in this case, what is A minus lambda? A minus lambda is 2 minus lambda, 3, 3, 4 minus lambda. Determinant of 2 minus lambda, 3, 3, minus 4 minus lambda. You can find out the determinant easily. This into this minus this into this. What is 2 minus lambda into minus 4 minus lambda minus 9 is equal to 0. This is the characteristic equation. You just see 2 minus lambda minus 4 minus lambda is minus 8 minus 2 lambda plus 4 lambda plus lambda square minus 9 is equal to 0. That becomes, what is its value? Lambda square plus 2 lambda minus 17 is equal to 0. Then you have two roots for lambda, and these are the eigenvalues. Eigenvalues for that particular matrix. Eigenvalues, as I told you, they have got lot of applications in quantum mechanics, vibrations and structural analysis, computer science, data analysis. And you please try to find out what is the lambda value. The lambda value will come to how much? Three minus 4. Now, you just see here, you got the characteristic equation. In what way it is going to help? In mathematics for you, in your examination. Even though directly some things are not there, like eigenvalues, eigenvectors are not there in your syllabus, but still I am teaching you. The reason being, if you understand these things, definitely you will be able to do better in the examination when you know these things also, advanced things. Nothing wrong in gaining knowledge. What is the characteristic equation and what are its use? I will tell you. Characteristic equation first. Let us think about it. What is characteristic equation? Determinant of a minus lambda I is equal to 0 is the characteristic equation of a given matrix, where I is the unit matrix and A is the given matrix. Now, here, what is the characteristic equation in the example we have got? Lambda square plus 2 lambda minus 17 is equal to 0. Can we bring this when this is the characteristic equation? You can replace lambda with A square minus 2A plus minus 17I is equal to 0. Is it plus or minus? Plus. This is Cayley-Hamilton theorem. This is Cayley-Hamilton theorem. It has certain restrictions that I will speak afterwards. Let us just try to understand this. Now, A square plus 2A, lambda I have replaced with A. Then what happens? You see, A square plus 2A is equal to 17I. Do you agree? Then multiply both sides with A inverse. A inverse into A square plus 2 into A inverse into A is equal to 17 into A inverse into I. When unit matrix is multiplied with something, the same matrix will be repeated. That means A inverse into A square is A plus A inverse into A is I is equal to A inverse into A. Because unit matrix, when inverse is multiplied with the same matrix, then it will produce inverse matrix. A plus 2I. Please see this, very simple. 2I is equal to A inverse into I is nothing but A inverse. 17 A inverse. Then 17 A inverse is equal to A plus 2I. That implies A inverse is equal to 1 by 17 into A plus 2i. Just imagine how simply you know A, you know 2i, how easily we have found the A inverse within seconds. Inverse of a matrix can be found within less than a minute if you use this particular Cayley-Hamilton theorem. Provided you should solve for the characteristic equation. From characteristic equation you will get the eigenvalues. The value of lambda is the eigenvalues, and eigenvalues have physical meaning. And as far as the syllabus is concerned, you got an inverse of a matrix in your syllabus, and inverse of a matrix can be easily found out when you know the Cayley-Hamilton theorem. Even though it's not explicitly given in your syllabus, I feel it is better for you to understand this Cayley-Hamilton theorem and uses of the eigenvalues. Eigenvalues you can solve this quadratic equation. I don't want to go into that small things where a quadratic equation, if you want me to solve also, we can do this. Lambda square plus 2 lambda minus 17 is equal to 0 implies, what is the value of lambda? Lambda is equal to minus 1 plus or minus 3 into root 2. Minus b plus or minus square root of b square minus 4ac by 2a. That formula you apply, you will get it. And here you will get lambda 1 and lambda 2. Lambda 1 is equal to minus 1 plus 3 into root 2. Lambda 2 is equal to minus 1 minus 3 into root 2. These two are the eigenvalues. And uses of the eigenvalues and how eigenvalues are connected to your determinant, and how to find the eigenvectors, and also how to find the inverse within seconds. What we have spoken till now is matrices definitions, arrangement, how a matrix is arranged, and we have spoken about determinants. What are the uses of determinants? And we have spoken about simultaneous equations. And we have spoken about for eigenvalues. Before eigenvalues, what we have spoken about is characteristic equation. Very important. Simultaneous equations, solutions, numerous solutions, unique solution that we have found. Characteristic equation. From characteristic equation to find the eigenvalue. And finally, from characteristic equation to find inverse of a matrix easily. What are the conditions under which inverse of a matrix can be found? Those conditions and other things we will discuss whenever this topic in full comes in front of us. This is how I thought I will make up my linear algebra. We will call it as linear algebra or matrices or determinants chapter, and we go from class 11th stage to JEE Advanced stage. We will be solving the problems like questions being asked in JEE Mains, JEE Advanced and Maths Olympiad. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture and video. If any value addition is taken place because of this lecture to you, please subscribe to my channel. Maths and Science by IITian. Share, view, review and other lectures also. There is one playlist, Mathematics by IITian playlist name. I will give the link of that in the description. Please pay attention to this introductory class. It has given you enough of information about matrices and determinants and the syllabus being covered. And I am not going into the advanced topics of vector spaces. And even eigenvectors also will be of little bit of higher level, but still I will give some introduction and some amount of what you call problem solving techniques with eigenvectors also for your additional knowledge. Best of luck to everybody. Thank you for listening to me.